let's get... All right, let's get this show on the road. Sorry, starting a little late. I don't know. How many people are California natives? Because, more than I expected. I'm not. Maybe it's a New York thing, always a little after the hour or after the minute. Actually, California stuff cracks me up sometimes. I got down to the beach the other day, and I saw people pulling up in Jeeps with surfboards on the roof, going out for a morning surf. It just cracks me up. I don't know. It's kind of like something out of a movie. But, yeah. Yeah, I should have seen David Hasselhoff somewhere. Anyway, yeah, welcome to the Dev Track. I feel really, really honored with all the speakers this year. I think we have a great group of people willing to share their knowledge. I was really excited to have Dave MacLachlan from Google. Kind of funny. I don't know if you're going to launch into the story of the email from Neil. I don't want to ruin that for you. So Dave is going to be talking about iOS development at Google, which kind of seems a little, like a wolf in sheep's clothing sometimes. But Dave is the lead on Google Maps for iOS. And yeah, that's awesome. So Neil sends out this email the other morning about Apple Maps getting people lost, and Dave just must resist commenting, which I thought was pretty great. So you don't need to hear me prattle on any longer. I will let Dave get right to it. Thank you, Dave.
Okay. I'm just going to stay away from Ed for a second, maybe a little lower on the volume. Okay, cool. Hi, I'm Dave MacLachlan. I'm tech lead on Google Maps. Based on the applause, it sounds like I haven't got too many of you lost, which is excellent. We try not to do that too often. I'm actually not out of our Mountain View Googleplex campus anymore. I'm out of Kirkland, Washington, which is right near Seattle. Actually, a lot of our map stuff is done out of our Seattle office. So, welcome to the 2013 MacTech Developer Track. I'm happy to see some folks out there in the Developer Track. I went to dinner last night with about 40 IT guys and wasn't actually sure there was any devs, so this is great to see. This is my first time at the conference. Honestly, when I got first asked to talk, I wasn't quite sure what I was going to talk about, hence the very general title. I was hoping I'd get a chance to see some of the other presentations, get an idea what things were like, and then they put me first. So I'm kind of flying by the seat of my pants here. Please be kind. Anyway, I'm also going to walk back and forth a lot because I do that. Google, aren't we an Android shop? Yes, we do some iOS stuff too. Let's be honest, we are an advertising company. We like people to see our ads. We like to think we make cool stuff, and you can come see our ads. And we're happy to have you using our services on whatever platform you should choose. If you talk to my execs and ask them, I'm sure they will give you a preference. But in general, we do a lot of iOS development. If you go to the Googleplex or you go to any of the campuses and take a look around, it looks kind of like this room right now. This could be a Google room. Their Mac laptops are ubiquitous. They're everywhere. And there's people in this room who spend most of their days actually supporting them, which is great. So, iOS development at Google. I like to think that people think iOS and Google, they think Maps. It's kind of near and dear to my heart. Luckily, people seem to like it. We've gotten a couple downloads. We're not Angry Birds Star Wars or anything like that, but it seems to be good. Our big 600-pound, actually, I honestly really enjoy working on maps. We've got, you run into random conversations with people all the time who want to tell you where they got lost or where their house is or why things don't work for them. And my aunt is OCD about our Street View cars, or she calls them the Google Whirly cars. She wants to know where they are at all times. I guess we took a picture of her front lawn and it was half cut, like her lawnmower is sitting out front, and she's very upset about that and wants us to fix that as soon as possible. But our big 600-pound gorilla is YouTube. Millions of teenagers with iPads, can't be wrong. But other than that, we've got sort of our flagship apps. Earth and Search have probably been around the longest. In fact, when we first released Maps, the Earth guys were teasing us on our own Twitter feed about, what took you so long. Let's see. Whoop, slide next. There we go. When you go to the App Store, we're actually one of the biggest, if not the biggest, iOS app developer around as far as external app goes. I think we've actually got more apps than Apple does actually on the App Store. And when I checked this morning, these were the 30-odd apps that we had available for folks. And 30 apps is a lot of Objective-C code. And we do write a lot of Objective-C code. The question that is interesting to me isn't so much how do we write it, is how do we maintain it. Now, I mean, coming up here and saying I'm with the Google Maps team and was going to talk a bit about Google Maps, people would think, oh, I'm going to talk about rendering or some cool OpenGL thing. And unfortunately, putting together demos for rendering in OpenGL is really, really hard because people expect really, really snazzy stuff. And I'm just not that good at doing snazzy stuff. So I am going to attempt to keep you awake for the next 25 minutes or so talking about unit tests, which is where I actually spend most of my time living, and how we use them. Because as far as I'm concerned, the unit tests these days are some of our most important code. The unit tests, I mean, if people talk about it being industry practice, I mean, I understand for smaller groups it may not be worth it. Certainly for bigger shops, I consider these to be indispensable. They are the best documentation your code is ever going to have. You can write documentation, and I mean, I'm sure we've all seen it, documentation, and you've read the docs, and then you've looked at the code underneath, and there is no connection whatsoever between them. In fact, I've seen documentation on the documentation asking what the hell the documentation above it was referring to when talking about the code that the new documentation didn't even refer to. I mean, the unit test, as you write it, sits there and tells you a whole bunch of things. First off, if there's no unit tests, you can basically assume the guy was incompetent. If there are unit tests, you get the idea what they expected for inputs, what they expected for outputs, what corner cases they actually thought about when they were writing the code, and hopefully you can extrapolate what corner cases they didn't think about by sort of reversing that logic. And more importantly, when your code changes in such a way that the unit tests are no longer valid, they will break for you and tell you that your documentation is no longer good, which is awesome and beautiful. So, unit tests, what do we do with them? We use the exact same tools in general you guys do for Objective-C. SendTest, aka OC test. It goes under both names depending on what year you started using it. And then, of course, Apple's recently introduced XC test, which is kind of SendTest. They want to say on steroids, but right now it's basically a wrapper around SendTest as far as I can tell. Some of the other third-party stuff we're using is the same as you guys do. OC Mock and OC Hamcrest. We've done contributions to both. Google Toolbox for Mac is a little thing that we use internally. Most people who use it externally use it for some of our unit testing stuff. And then I mentioned Cover Story up here. A, because I wrote it, but B, because I'm going to use it in my demos. It's a nice little UI for looking at. A nice little UI for looking at code coverage. So in general, I'm using the royal we for the Google we, are really happy with what Apple's done with unit tests. Especially in Xcode 5. I don't know if you guys have played with it, but XC test is really nice. You can create your own tests straight up. You can, they've got their little build farm, which is really nice for smaller shops. You can turn on and off individual tests. And the only place right now that I really think they're lacking and would love to see fixed is coverage. Because you can run your tests. And you can tell me, I can tell you that Maps has 2,567,000 tests. It doesn't. I wish it did. But if you can't tell me what code is actually being covered by those tests, they're almost useless to me. Especially as you can see down there, I've got the historical record of coverage. I mean, I've got product managers who are coming to me asking, have our tests improved? Have they failed? I mean, it's a good way of measuring how confident you can be in releasing your app. I mean, these weeks, we're releasing a new version of Google Maps every 4 weeks for iOS. And so that means we've got pretty tight turnaround schedules now for getting things in when you consider that, I mean, it's got to go through the App Store, it's got to go through review. I'm sure you guys have all dealt with this. There's a fair amount of time that's burned just on administrivia as opposed to actual coding and QA, which is where most of us want to spend our time. Well, most engineers want to spend their time. So, aha, people scream. There is code coverage in Xcode. There's Gcov. And yes, there is Gcov. Gcov, for those of you who aren't aware of it, came with original GCC. I think it was actually written by the Richard Stallman with GCC. And it does work. Except it and X could have had a bit of a, let's put it in Facebook terms, a complicated relationship. Xcode 3, it worked great. But I mean, we were all doing just straight Mac development with GCC. I mean, they would have had to work to break it. Xcode 4, it worked with GCC, but this is when they were starting to introduce Clang and LLVM, and there was absolutely no support in LLVM for it. Xcode 4.2, they actually added some nice little settings in the settings dialog box, if you knew which ones to go for, but they were broken and didn't actually turn on what they were supposed to, and you actually needed to link in the libraries by hand. But you could do it. Xcode 4.3 was a stellar release in that they gave you all the bits and pieces, but they actually forgot to compile up the profiling library in x86, so you couldn't do it on the simulator. 4.6, you could get going with some added code, but that's when Apple was really starting to push, maybe you're a little bit wrong on my schedule or on my dates here, but they were pushing the individual app tests versus logic tests and unit tests. And I don't, if anybody doesn't know this, you don't need to worry about it because they actually threw this all out with Xcode 5, where once again it was working. However, they threw in the twist of XC test. So now if you were doing send test and XC test, you actually have to do some different code. So let's actually see what it takes to turn on code coverage. And I'm going to attempt to switch screens here. I'm going to have to duck behind to trans. Do you see a, yes, we see a map. Excellent. Okay, and I'm actually going to do the no and code in front of you. So this is a chunk of code that I wrote up. It's extremely complicated. Can people read that somewhat? Okay, the view controller does absolutely nothing. The delegate does something good and it does something bad. That's all it does. And then down here I've got, oops, wrong view. And down here I've got my test. There it goes. It's a nice little standard XC test case and it tests it. So I'm just going to prove that this actually works by compiling, running, and the build succeeded. Here goes the simulator. And if I go to my test log, test today ran, hooray. And if I click on it, it should say something like good dog somewhere in there. There it is, good dog. All right, test ran. Now, in this simple example, I know very well that I didn't actually test my bad dog case. But if this code was any more than 15 lines, it rapidly becomes complicated to know what actually got covered, especially when you've got weird and wonderful cases like this needs to, testing in versus Japanese calendars, weird time zones. For us with maps, weird borders. Who owns those islands south of China? I don't know. Becomes issues for us all the time. So what I'm going to do here is I'm going to turn on code coverage as we're supposed to. Now, I went to Stack Overflow and looked into it. And according to Stack Overflow, if I go here and type gcov and turn on generate test coverage files, these were the bits that didn't actually work a couple of versions back. And I go and I type in instruments and instrument the program flow. I should now be able to run it, and it should run my tests. It did. It recompiled, and I should be able to go to my derived data, and here's X. Let's open that up in the Finder. Here's XC tester, and I'm going to drag it down on cover story here, and it reports nothing for me. Awesome. Down at the bottom, you can see there's a little yellow line there that says found no GCDA files to process. Well, that sucks. So to figure out why we don't have any GCDA files, I'm going to have to go back to slides. Let's see if this transfer works as nice as the last one. Please tell me when you can see something. Hey, okay. gcov. So we turned on those two flags. We turned on the generate test coverage files flag, or -f test coverage if you're into command line stuff. And that adds all the individual instructions for actually counting the number of individual lines are executed. The instrument program flow, or the profile arcs, actually figures out which branches you dive into. So it's kind of cool for knowing, how many times did I take the left branch versus the right branch, or switch statements. Turning on both of these flags is supposed to link in a little library called libprofileRT. And I'll tell you that the fact that our code actually ran with those flags turned on meant that it did link in that library correctly. So we're all good there. So The thing is, we've got these GCNO files, and I forgot to actually show you earlier that we did generate them. I'll prove it to you in a second. But the thing that we were missing was these GCDA files. Now, the GCNO files are gcov note files. They're generated at compile time. The GCDA files are the actual data files that are generated at runtime. So the question comes up, why didn't we get GCDA files? Well, we have to take a look into actually what gcov is doing. And I actually went and got out the source for LLVM and dug through it to find this incredibly deep and dark information. And there's gcov init and gcov flush. They're actually called LLVM gcov init and LLVM gcov flush. But they are set up and run to gcov init, starts the counters as you'd expect. All of your data gets stored in the counter. And then gcov flush is the important one that needs to be called to get GCDA files out. So the question is, where did gcov flush not come out? Now, a key thing to read here is there's that I've highlighted. It has to be called, gcov init has to be called for each library executable, and gcov flush must be called for each library executable. Let's put this in. Let's actually put a graphic up on the screen. So this is how Xcode actually runs your tests. You've got your app code, and it takes and injects a dynamic library. Of course, there's no dynamic libraries on iOS, but yes, it injects a dynamic library into your code and runs your tests with that injected code inside of the app. And as I said, each executable unit has its own gcov init and its own gcov flush. Now, it would be really nice if we could call gcov flush from our test code, because we're not getting there for some reason. But you can't, because if you call gcov flush from your test code, you're just going to spit out your test. You're just going to spit out coverage data on your tests. And that's not really interesting to me. I mean, I'm already told that all my tests have executed. What I want is the gcov flush called on my app code. And that's where things get a bit tricky. So what can I do to get gcov flush called from my app code with this whole injection scheme? Well, normally I think of 3 different ways to get code run at the end of an iOS app. First off, Apple has nicely documented an application will terminate method that my delegate can have. That's the nice iOS Objective-C way. Going a little bit lower level, we get into POSIX type stuff, and there's the @exit function where you can register an exit handler, which is kind of cool. And then even going a little bit lower level, there is there is destructor attributes that you can apply to functions and have them actually called at QuickTime. So let's go to a quick demo of those. Whoops, that's not the escape key I meant to hit. I meant to switch screens. Again, please let me know when you see something. Good. Okay, so let's open up. I'm going to switch back to Code Warrior. My goodness. I'm going to switch back to Xcode. And I'm going to pop up a little program called Exeter. Okay, so what's Exeter do for me? Well, it actually covers all of those things that I was talking about earlier. You can see at the bottom there, I've got an application will terminate. I've overridden that. I've overridden application did finish launching, and it registers an @exit function there. You can see sort of in the middle here. I'm kind of pointing with my cursor. And then up here, you can see that I've got a constructor function and a destructor function properly set up so that the compiler knows what to do with them. So given my code that I have sitting there on the screen, I would expect that I would see did finish launching, then I'd probably see constructor hit, then did finish launching, then will terminate, then @exit hit, then destructor hit. Now, I'm not really sure how the @exit hit and the destructor hit, what order I'd expect those in, but honestly, if you're worried about the order of how destructors are running at the end of your code, you're doing something wrong. So let's just run the tests here and see what we get. Compile, compile, compile. Build succeeded, launched, done. And I head to my test. And I'm going to get logs on the whole thing here. Well, you may not be able to read this, and unfortunately I can't increase the font size, but constructor hit was hit. Did finish launching was hit. Registering an @exit method actually failed and spit out number 3. And if you check out error_no.h, that's no such process error, which is odd considering I'm a process. And then you see all my tests run, and neither my did finish launching, nor my destructor, nor my @exit, well, we wouldn't expect the @exit anymore, actually get hit. So what's going on there? Well, this has to do with how iOS 7 apps actually run. I mean, iOS 7 apps don't exit. I mean, they abort, basically. A controlled crash. I mean, the only time your iOS app really exits is when you get, I'm running out of memory, you better do something. You get it 3 times, and then they kill you. And your tests, in this case, basically do the same thing. I have no idea why Apple has left the add exit method even there, because it doesn't do anything. It's basically a no-op. So given that, what can we do to actually get our stuff to, how can we get an XC or a gcov flush in there? Well, what we need to do in this case is it would actually be nice to watch the tests as they're executing, and when all the tests are done, have the testing side of things spit out a gcov flush for us. So what I'm going to do here is I'm going to add some code that I wrote ahead of time, because there's no way I would code this up in front of you. Whoops. Because A, it would be boring to watch, and B, I would screw it up. But I'm going to throw in a method to the app. And I'll show you what these do in just a second. Good, I'm adding that to the app. Go back to the Finder. I got Google Test Coverage XC. Excellent. I'm going to add that to the tests, and it goes into tests. Good. OK, so what I just added to the app. Ignore the defines up top. We'll talk about them in a second. But I did a category and tossed on a nice little method, gtm underscore gcov underscore flush. No, this isn't normally how I name methods in Objective-C. However, categories are such fun little things with the fact that you can have name collisions. I like to name them really weird and wonderful stuff. I don't normally use a lot of categories for code that I ship. But it's perfect for what we're doing right now. And so now I've got the ability to call a gcov flush inside my application code. On the testing side, I need to actually get it called. So I go over to into my tests, and there's a really fun little class called Test Observer, XC Test Observer. You can see that I've subclassed here. And what a test observer does is pretty much what it sounds like. It watches all your tests. And one of the methods it has is stop observing. So I can, when the tests are done, I get stop observing. I get my application. I check my application, and if it supports GTM gcov flush, I call it, and everything should be good. The interesting thing about XC Test Observer is how do you get one of these things created? What creates your observer? Now, by default, Apple has their standard observer that gets created, and that standard observer spits out all the logs that you're used to seeing. Now, this actually goes back to send test, but what happens is, and I'm going to jump into what the other code here in GTM code coverage. The way they figure out what class or what observers to instantiate is by looking at NS user defaults for a particular string, and inside that string, they look for a comma-delimited list of classes that they should instantiate at runtime to observe all your tests. What's even cuter is I would like to have all this weird and horrible code in my tests, but the XC test observer mechanism actually, it depends on a load method as well. And for those of you who aren't familiar with the load method, it's kind of mystical juju. But load methods get run in no particular order. So I originally wrote this with all my load code in my tests, did practice my slides all week, changed the name of my stupid test class, and it broke all of my stuff because it was running my load methods out of order. My observer wasn't being registered, and I pulled out a lot of my hair like yesterday, which was really fun. But so now, the other thing that's kind of interesting here, if you've read the comments, is that I'm doing a lot of stuff with strings, loading tests by name there. The reason that I'm doing that is because I don't actually want to link XC test into my application, and I'd have to do it otherwise. Now, I can somewhat redeem myself by saying on the test side, it also has a load method. And that load method, all it exists to do is verify all the assumptions I made in the other load method, because it can link against XC test. So it sits there and verifies that Apple hasn't gone and messed up any names on me or anything like that. Anyway, after all this low-level infrastructure, let's see if it actually works. Build succeeded, it runs, out it goes. And if I go to my XC tester here, drag it onto cover story, oh, please. Let's try again. Now cover story is being mean to me. There we go. And if I take a look on my app delegate, there, I actually have code coverage finally, and it tells me that I'm missing my test. But it can be done. These classes, I haven't actually published them to GTM yet. I will put them out there. They look ugly and nasty, but they're actually relatively easy to use, and they are stuff that we're using in maps right now to keep code coverage numbers alive for us all the time. So, back to slides here. Maybe. Please. Force acquire the screen. There we go. Okay, so another thing that's interesting about my code is that I deal a lot with what we call cross-platform code, especially in the renderer level. Objective-C is, in general, a very fast language, and the dispatch is great for most UI-type stuff. However, quite honestly, my life is split into 16 millisecond chunks. That's what I need to get 60 frames a second. I have 16 milliseconds to draw a map on the screen, and your little cursor guy, and whatever other data that needs to be laid out there as it's moving in real time. And the Objective-C dispatch actually adds up to a fair amount of that 16 milliseconds. I mean, they squeeze 4 milliseconds off me doing Objective-C dispatch, and it's a quarter of my time. So we do it in C++. Problem is that the testing frameworks as they exist don't actually support C++. And the one that we use internally, and actually the LLVM folks and Chromium and a whole bunch of other people use is Google Test. It's a relatively nice little cross-platform C++ testing framework. So I'm just going to quickly show you how we go about getting that into with more test hackery, how we get that into a test. Switch over again here. All right. Now, I'm going to quick cover story for a second, and I'm going to move over to a send test version of the exact same code that we had, because we honestly haven't moved most of our code over to XC test yet. And I just want to show you real quick. You'll notice in my code coverage app here that load stuff that I had only exists for XC test. It's only defined for XC test. That's because send test, the old busted stuff, actually sends out notifications to tell you when tests are done, so I don't have to do any of this load stuff. I just listen for notifications and just deal with it. So it's quite a bit nicer. I can just count the sweets. So I'm going to take some random C++ code that I have here. CPP, whoops. So here's a random C++ file. I'll toss it into my tester app. Good. Get a random C++ test. I'm going to toss it into my tests. Excellent. I would compile it up right now, but I need to pull in the gtest stuff. So I'm going to go into third-party, gtest here, source, and I'm going to pull in this gtest no Google 3. Google 3 is some internal library stuff that we have inside of Google for supporting this type of stuff. Obviously, I don't have it here. And I'm going to hopefully build my tests. Oh, by the way, well, it's building. Here's what C++ tests look like. Of course, they're done with macros. It's C++. So, and you can see that I have test good dog CPP and test bad dog CPP. Let's take a look at my logs for this run. Tests, run unit tests. Oh, no, I've got bad dog Objective-C and good dog Objective-C, but I don't have my C++ code. So how do we fix that? Well, yet another GTM class. And it's called the GTM Google Test Runner. Naming isn't one of my strengths either. And what this cool little thing does is it hacks into how sendTest actually picks up all the tests that it runs. And this is the same in XC test. You can do the same thing. I pretty much could replace all of the send with XC and it would all work. And what it does in this case is, by default, how the test system works is it looks through all your classes that are subtests of sendTest case, and then looks at all the methods inside of that and picks up all the methods that start with the word test, and then executes them, which for 99% of the stuff you want to do is perfect. In our case, with the C++ macros, it doesn't work at all. However, you can override the default test suite, and the code there, there's a chunk of code there, but it's relatively simple. All it does is initializes up Google Test, and then asks Google Test for the list of tests it knows about, and then actually creates a send test on the fly for each one of my Google tests. And we'll do that for each of my C++ tests. We'll register the entire suite for me, and then we'll run it by executing this method, run Google test, which does nothing more than runs the test, except the run Google test thing here does its own little trick where it adds its own observer to the tests. Sorry, I'm jumping around a bit here. But all the observer to the test does is prints out the test results in a way that Xcode expects to see them. So by adding that one little chunk of code, I should be able to compile up and run my tests. And they all run. I go to my logs. And if you take a look in here, you can see the GTM Google Test Runner. You can see that my tests actually show up as Objective-C tests. I can see them. They log out correctly. And even nicer is if I actually go in and break one intentionally, like we'll have it return true, and I run it, it'll break. And not only will it break, it'll do exactly what you'd expect with Xcode and show me exactly where the test broke. And no other magic. Well, we threw some magic in there, but no other magic required. Basically, the only thing it doesn't do, which is kind of unfortunate, is where in your list of tests, they don't document any. That's not what I was. Oh, okay. Well, they actually do show it to you after you compile. Sometimes you can see how there's purple tests versus blue tests up there. The purple tests are the one that are dynamically generated, and Xcode doesn't know about them until you actually execute your code the first time. So you can't turn them on. Anyway, I think I am basically out of time, which is good because I'm basically out of slides. Switch over here again, maybe. I hope I didn't bore you too badly with the chat. It was kind of inspired by actual coding that I was doing 2 weeks ago where I was banging my head against the wall and figured that I'd hopefully keep you guys from banging your head against the wall if you ran into the same thing. The list there is the radars that I filed in the making of this talk. So if any of you want to pile on. Yes, we file radars. Yes, they get duped. Yes, we never hear about them again. But yeah. I got told there wasn't time for questions, but I'm going to be around all week. Feel free to scribble down my email address or track me down, and I'd love to talk with you, and we can actually talk about rendering and OpenGL stuff if that's what floats your boat. Anyway, thank you very much.